Hello and thank you everyone for attending today's webinar, Need for Speed, How Additive Manufacturing Helps to Redesign Racing Motorcycles, brought to you by Design World and HP. We'd like to thank our presenters, Brian Case and Justin Hopkins, for being here today. I'm Mike Santora, Associate Editor for Design World, and I'll be your moderator. Just a couple of housekeeping details before we get started. You will see several boxes on your desktop, all of which can be moved around to suit your preferences. Initially, the Q&A box is at the lower left. This is where you will enter your questions for the Q&A session. Another box to note is the additional resources, initially at the lower right-hand corner of your desktop. These resources are for your information needs. We also have a tweet box right on the desktop, so feel free to tweet any interesting points right from there. And there is also a list of hashtags for you to use as well. Brian Case is the director of the newly established Barber Advanced Design Center at the Barber Vintage Motorcycle Museum in Birmingham, Alabama. The 230,000 square foot facility houses the world's largest motorcycle collection. Prior to joining Barber, Mr. Case was the co-founder and design director for Alabama-based Modus Motorcycles. He led the design and development of the company's line of unique production motorcycles and engines. Brian is a graduate of the Art Institute of Pittsburgh with a Bachelor of Science degree in Industrial Design with a focus on personal transportation. Justin Hopkins is an applications engineer with HP who works with companies to reinvent their manufacturing processes through the use of technology. Justin believes there are tools that help build the world around us, and we are now enabling everyone to have access to a tool that gives you the freedom to create and manufacture. He was previously in the education and design field for additive manufacturing for 13 years at the Rapid Prototyping Operations Manager at SCAD. He has spoke at Rapid and at AMUG on the advantages of the additive process in education. Justin holds a BFA in furniture design from the Savannah College of Art and Design. So now, without further ado, I'm going to hand it off to Brian Case.
Hello. My name is Brian Case. I am the director of the Advanced Design Center here at the Barber Vintage Motorcycle Museum in Birmingham, Alabama. It's a phenomenal facility if you ever had the chance to come here. It's got a racetrack, and as Mike said, it's the world's largest motorcycle collection. There are over 1,500 motorcycles in the collection currently, and about 1,200 of them are on display at any given time. We've got several hundred in the inventory in the warehouse that are awaiting restoration or preservation. It's a beautiful park and facility. It's on about 880 acres in the hills of outside of Birmingham, Alabama. So the Advanced Design Center, what that is about a year ago, I was tasked with coming up with a concept to add on to the museum here that focused on education, to expand upon our educational outreach. The Barber Museum is a 501c3 private foundation, and this design center is housed within the museum. It'll offer this unique multidisciplinary approach and creative space unlike any in the world. And by that I mean it's physically inside of the museum. The collection is arm's length away. There's 155 years of motorcycle evolution in the building. It's a great space to come and use it as a research library if you're in this field and be inspired, even if you're not in the field. Motorcycles are always fascinating machines to look at. They kind of show all of their parts on the outside. Very rarely are their internal workings covered up. So they're fun for all ages, and we see all types come through here and get inspired. And I've been coming here for, 16, 17 years now, almost since it opened 18 years ago. and I was inspired by all kinds of designs I saw here. I've designed motorcycles in this building. I would sit there and sketch in the atrium and just look at everything around me and use it for inspiration. So the Barber Advanced Design Center was a concept to put a name and a place to study these designs and serve as a satellite teaching studio for visiting designers and host special projects, one of which I'll be talking about today. There's a 3D printing lab and laser scanning lab. There's CAD workstations. We have surface plates for full-scale model making, prototyping, along with clay styling. There's presentation walls, including a new 20K resolution, 16-foot wide LED video wall for doing things like rendering and VR simulations. And so this is the project that I'm talking about today that we are in the middle of. This is a new, exciting concept motorcycle. And this was a collaboration with Pierre Terblanche. He's the automotive designer I'll talk about here in a minute. This is a collaboration with him. This represents a completely digital workflow over the past 4 months, and we're right in the middle of it now. Every part of this concept was 3D printed right here in full scale and quarter scale simultaneously. It was just kind of a fun little thing I did while I was sending parts to the printer. Why not just scale them down and send them in quarter scale at the same time? And I'll get more into that in a little bit. So all told, I've printed 250 parts, 50,000 cc's of part volume in 1 month on one machine. A little bit about Pierre, some background. Pierre's world-renowned designer, spending a lot of his time at Ducati, led the design for 9 years at Ducati, and produced designs such as the very popular Hypermotard, the Super Sport series, the MH900, which was the internet sensation in 2001. All 1,000 examples of it sold out in 30 minutes. The Ducati Sport Classics and so on, and also the 1993 Ducati Super Mono. So the Barber Advanced Design Center is now hosting this real-time design build with Pierre. And the goal is to reimagine one of his designs, the 1993 Super Mono, this mythical, iconic club racer that he did 30 years ago. So the Super Mono, this is what it is. The 1993 Ducati Super Mono is a lightweight, single-cylinder racing motorcycle. This was not a street legal bike. It was purebred race bike to fit the Super Mono racing series back then. Only 67 of these were ever made, and the original spec on this bike was a 550cc four-stroke, four-valve, liquid-cooled, 75 horse at 10,000 RPM. Had a unique feature that used a dummy connecting rod because Ducati at the time didn't have a single-cylinder engine to enter this series, so they needed a single-cylinder engine. They lopped off a cylinder of their World Superbike winning 888 engine at the time, and then made a dummy connecting rod on the rear cylinder, which allowed it to, it canceled some of the vibration that you typically have in a single-cylinder engine configuration, and that became its claim to fame. So the project that we are doing with this 30-year-old design is meant to demonstrate advancements in technology and computer software and tooling equipment that have developed over the last 30 years. The original bike was created at a time when there were no computers in the design lab. This, it was done completely analog with, traditional prototyping, model making, plywood, steel, and clay. And we are going to revisit this design and see how, modern tools can inspire new ideas. And through this process, we're going to be releasing a series of, blog studies on how the modern designer has to be more skilled and master all these new tools just to perform the same tasks that were done in an analog fashion so long ago. So we go back to the early 90s in Italy. This was the genesis of this design. This is 1992 in Italy. Pierre there is in the middle. This is the design team on this project. You can see there's some clay modeling there going on in the studio at the time, very small studio in a little town in Italy. Very hot, 100-degree heat in the summer doing clay modeling. You can imagine it was tough to keep the clay cool enough to even sculpt it without it turning into like ice cream. So this was a very analog process at the time. This is what fascinates me about this, is that even back then they were turning out designs like this, but everything had to be done in such a way to translate it to the tool makers at the time. And they had to do the clay symmetrical. It's a symmetrical body shape. So you have to do both sides of the clay and copy all of your points with these analog coordinate measuring systems on a plywood surface plate. Copy all your points over to the other side, and then lay up your fiberglass molds, do your gel coat, right on, build your walls and lay up your fiberglass and pull molds directly off of the clay. And that's how they made these 67 examples of this motorcycle. And you see there the parting out each of the shapes, making the parting lines and laying up the gel coat and the fiberglass to pull the molds. Very tedious work at the time. This is over the course of 3 to 4 months of just nonstop pulling all-nighters, making these crude models in analog design. There's the final result there just before it goes to paint, and the fabrication team there getting all the body panels to fit up together the way it would be built for the racetrack, and slap a coat of paint on it and throw it in the van and head off to Milan, where it was unveiled in 1992. There's the finished example there. This is a photo of the one that we have in the Barber collection. We have number 38 of 67 examples, and it is a mint condition 0-mile bike. We've never run it, and it's just a perfect specimen to do a deep dive study of this machine 30 years ago. So invited Pierre out to the museum. This was late last year. It came out to the museum on holiday, and we had the machine pulled out down in the restoration shop. We started dissecting the design and pulling panels off of it, and he's getting emotional and remembering what it was like for him 30 years ago. And he's stayed current on all the latest tools, and primarily works in CAD now. And he's remembering having to do all this work at a time when there was no computers around. So it was really fun to witness this late last year. And so we just dissected it, kept peeling back the layers of the onion, and taking the body off. And I really had just a profound appreciation for this particular machine, how cool it was. It was so tiny and so simple in its layout, or logical, not necessarily simple, but just logical in its layout. This tubular steel frame and monoshock rear suspension and so forth. So the next best thing to do was sit Pierre down in front of a camera. So I did an interview with him and talked about all these parts and asked him to look back and remember what it was like to design these parts back then. And it was really great. And this interview is on YouTube, and there's a link included at the end of this presentation if you want to watch that. But it was just a great conversation I had with him, remembering this time inside of a little studio when Ducati was a very small company. And this inevitably led to the main topic of this presentation, which was, what would he do today if he had it to do all over again? How would he use the tools of today? And so here we are sitting in this, the world's largest museum, with the opportunity to do something about that. And so we pulled out the laser scanner and digitized the entire motorcycle. And that was really cool for me because as I was scanning it, I was realizing that no one that I know of has ever scanned this machine. It doesn't seem like it's that old, but it is 30 years. It's 30 years old, and there was no CAD model of it. So we scanned it all in, and the resolution that we're able to achieve today is just amazing. And it's really sped things up. I was really excited about this process because, you're kind of skipping the point cloud step now. You're scanning directly to a polygonal mesh that you can fill the gaps. The software is so advanced now, it just speeds the whole process up. And you can, in just a few steps, export, mesh models and get them directly into SolidWorks or whatever. And it just speeds up the whole workflow. So started to break things up into components, and really all I needed was just some reference planes, for Pierre to start with. And I got more data than, we needed, but you can just see the resolution there, picking up the decal thickness. It's just amazing. And just different parts there. This actually, let me go back there. I mean, that's a fully closed object, and just a few steps out of the scanning software, patching holes and defeaturing some areas to get a fully enclosed mesh model. So what we did with that data is, we brought it into the CAD environment to get some planes and reference planes, some cross sections. So we were holding true to the original design as we moved forward, and Pierre started blocking out shapes of what would become the new concept. And these are concepts, aerodynamic concepts that he's been wanting to do for 20 years, 30 years, even since the original. And now with CAD systems, like quick CAD sketching programs, is able to work through these. So the highlighted area there in yellow is kind of the central part of this design, which is the radiator ductwork that flows air through the central area of the bodywork through the heat exchanger. So this is where we were just a few weeks ago, getting the body, all of the surfacing details finalized on the body and broken up into different shapes that we're going to send to the printer. Some final body shapes there, and some getting into some Class A work with Filippo Corticelli on doing some of the alias work. and getting these panels broken up to feed to the printer. All of the bodywork was 3D printed. Showing some parts there. That's the intake. So this is the mouth of the radiator ducting that goes through the central part of the bike. So the whole central part of the bike is hollow. And you can see some of the alias work there on the surface continuity work that Filippo was doing. And we're getting into doing some renderings right now. Actually, this is just the start of some of the colorways. And then, of course, 3D printing. A project like this really couldn't have come together so quickly without, a machine like the Multi-Jet that I really have a fond relationship with now. I love this machine. It just is a workhorse. Producing 250 parts over the course of a month. That most of which was in the last week. And I ran this machine around the clock, and it's just all on one machine. So this is that was not going the right direction. Yeah, so I'm just pulling parts out here, and it's in 20 years of 3D printing, I've found that this machine just has a really nice, efficient workflow. And it's not at all complicated. Pulling the parts out and unpacking and dusting them off and bolting them on the prototype is really nice. So just showing some of the full-scale parts here that I'm pulling up and starting to fit together. I mean, you can see here I haven't even cleaned this part. I'm just pulling it right out of the processing unit and fitting it to the prototype as I go. And that's showing the wheels. Have completely 3D printed the wheels, and we did them in pieces and spokes, individual spokes, just to fit, all of the parts together in one build unit. Really, for the sake of time, I needed to get the whole concept together for an event, so had to get everything in the machine loaded, and so we broke up the wheels and glued them all together. And that's the final wheel there. An interesting concept here. This is one thing that will definitely go to metal printing, is the brake disc. This is a concept that Pierre has a built-in heat sink, so it's definitely a candidate for a one-piece metal print, potentially in aluminum, like a stainless clad aluminum metal print with this fluted heat sink. And it's just showing some of the parts all laid out. And there's the quarter scale model. I had so much fun just doing the quarter scale model that I found, I would totally do that again. Is while I'm printing in full scale, I'd print the scale model at the same time. It took very little effort to just scale everything down 25% to 25% and then print it. And it allowed me to figure some things out on the fly before I even printed the full part. Found some little mistakes we'd made and so forth. So there's the little model. Used scale screws too. And then this is just showing some of the last build chambers. It's probably one of the more challenging things is it's like a giant 3D puzzle, fitting everything in to get a good workflow efficiency here. This was all 30 spokes that I needed in one build, plus the sprocket, because I actually ran out of time to even order a sprocket, so we just printed one. And then some of the last builds there, just really compact. The one on the right there is I just jammed everything down as close as I could get it together to maximize. This is about a 12-hour print, so just needed to get the last few parts done, and all worked beautifully. And then started to mock up and things bolt together and things just go together. The accuracy, the speed and the accuracy of the multi-jet is I'm really impressed by, and I'm really looking forward to flexing its muscles, so to speak, with more projects. But it was such a relief, just to pull things out and have things not need to have extensive post-processing to them. I mean, it was just, print and assemble. So that's some of the concept going together, and this is just last week. That's where we're at on this project, is getting the final bits bolted together, and it's all conceptual at this phase. It's the black part you see is the frame of the motorcycle. That is the air intake for the radiator, which will live right in the central part above the engine. And it will all be 3D printed and make use of the flow of air through the central part of the motorcycle as efficiently as possible. We've got the real parts there. The cylinder head, of course, is scanned. This is a Ducati-based design, so we scanned the cylinder head, and like I was saying, it's a completely digital workflow. So Pierre is in South Africa right now, and I'm in Alabama. So I'm scanning things, and then like in real time, I'm just emailing it to him, and he's packaging it, throwing it in the model, and packaging and moving through the design very quickly. Doing adding little features that wouldn't be possible really with the tooling of these parts. So adding some color features, these little perforated areas of the bike to let some color shine through, and only be possible through additive technologies that we're doing on this project. And that's where we are today. This is in the studio here right behind me, and so the whole concept is mocked up, and we're continuing on the evolution of this, and the tail section and the exhaust system that we're going to show off here in a few weeks, and how the exhaust system integrates with the radiator, the heat exchanger cooling system, so that all of the hot air dumps out behind the rider in the low pressure area behind the rider, and completes the aerodynamic shape of the machine. And some aero work on the front end with the front suspension system, which is very narrow, again, to improve on aerodynamics for a racing motorcycle, get everything as narrow as possible, punch the smallest hole through the wind as possible. And so that's where we are. So this is the scan code. If you want to scan that, you can go and watch the interview to learn more about the background of the project. But I guess at this time I'll flip it back to Mike for some Q&A. Thank you.
Excellent, Brian. Thank you so much. Like you mentioned, I am going to now open it up as some excellent questions coming in. So we're going to take them to the audience. So, all right, right off the rip, good question. So we'll start with, Brian, Justin, what was the most challenging part of the project? Scanning, design, printing, or finishing?
I would say challenging. There's probably the most challenging for me. I mean, Pierre would probably say, getting the concepts out of his head, right? So some of these have been brewing for 30 years. And what the Advanced Design Center at Barber allowed him to do is get those out of his head, concepts that wouldn't necessarily be feasible in a production environment, or with things like, marketing and promotion and, scaled production getting involved. So this was a purely design exercise of what would you do if you could do anything. And so that would probably be the biggest challenge for him, is getting those ideas out. Something like the 3D printer and the multi-jet specifically just kind of eased that challenge. It's just like anything you can send at it, it can make. It's almost like there are no constraints. So, and Pierre is the one that actually recommended this machine to me, because he had done a project before using this specific machine. So he said, point blank, like, you need this machine to get this project done. So on my side, I'm like the model maker in this scenario, right? Learning from a master designer. And the most challenging thing for me was probably the packaging of the parts in the build chamber. Like that was like hurt my brain at times, right? Because you wanted to be the most efficient at packing them in to get the most out of your machine and make the materials go the farthest. So it's like it literally is a challenge to try to do it as best you can, right? And I really wanted to get better at it each time I did it. So I did 20 rounds of prints, 20 separate build chambers in 1 month. And each time I did it, I got a little bit better at packing. And there's third-party software that does kind of auto packing, right? And I tried some of those, and I just ended up liking doing it myself. Like, I just wanted to kind of manipulate it the way I wanted to do it and orient each part individually to optimize the surface quality and get as many parts in there as I could. And so that was my own personal challenge that I just, took it upon myself to do. But, that was probably it.
Yeah, piggybacking off that, and you did touch on this briefly, I think, but maybe just again, if you were to do the project again, what would you do differently?
I probably would have allowed more time.
Yeah, right.
And that's the universal answer, right? Every designer wishes they had more time. And Pierre jokes about this all the time too. Like, he wishes management gave him an extra year. Tell me the year before you actually need it done. And that never happens, right? You always have deadlines, and the deadline is what forces you to put the brush down. So, if I had it to do again, which we will, this is the first of many projects here, I would say that, I would have more time to double check the fitment of my CAD models prior to posting it to the machine. Because what I learned in doing the quarter scale model is I was kind of staying ahead of myself by printing the quarter scale parts in a previous batch that I knew I was going to need in full scale the next day. So I was kind of learning on the fly where, there's a couple parts that didn't quite fit together. We used the wrong file version, printed. I mean, it was hundreds of CAD files that I was managing all at one time. So a couple times, like, the wrong version got sent, and I had printed it and it didn't fit. So being able to do a quarter scale model just takes up a lot of space. And so I was able to fit things together, realize, we made a mistake. Now I can print it at full scale. So I would just do more of that in the future.
Sure. All right, Brian. So here's a great question, one that I know I certainly have. What's the plan moving forward with the bike? Is it just going to be a concept display, or are you going to make it functional? Good question.
Yeah, I think we had an event, a reveal event here last week at the Barber Vintage Festival, and it was just kind of a teaser for who came out for this event, and they got to see the concept in the flesh. And that was the inevitable question, like, when can we see it run? And when you're in a museum full of thousands of motorcycles, and there was motorcycles everywhere that weekend. It was just kind of a resounding yes, like we have to build this thing. So it is, in its current form, it is a concept model. It's just meant to inspire and answer the question, what if you could get anything out of your head, what would you do? And it could very much be built. It is a sound concept. It's not a pie in the sky concept. It is based on an internal combustion, a single cylinder combustion engine. So it could very easily be made. So that we're leaning in that direction. And of course we have a racetrack. So this would be the perfect place to build that prototype and actually run it. So I, for one, would very much like to see it built.
Well, I'm putting my bid in right now. Please build it. I want to see it too.
Yeah.
So yeah, that's my opinion. Yes, build it, please. Okay, so in terms of the production itself, you mentioned Pierre actually had said, this is the machine that you need. I know that you've worked with other 3D printers in the past. What would you say some of the positives and negatives of working with the HP printer are?
Definitely the speed, I would say, maybe speed and accuracy. From day one, from plugging it in, I was impressed with what you immediately learn is just the technology behind the machine, how it's not a single point method of construction. It's an entire bed plate of construction. It builds one layer at a time, as opposed to like a single point laser or curing process. So, and I didn't fully understand the benefit of that until I saw it in operation and how fast it is. I mean, we're talking like 9 seconds it's building a layer. And so I really came to love that feature of it, because it's almost like free parts, right? You've got a build chamber that it works on a Z-axis. So it prints a layer and moves down in the Z. So let's say you're loading a part that is 100 millimeters tall in the Z height. Well, you might as well throw in a bunch of other parts that are underneath that layer, because it prints in the same amount of time. It's printing the entire layer, slice layer at a time. So I would say that equates to speed. You're printing parts in a matter of hours, and with not having things, because it is like a binder jet, it's a powder-based technology. You're not dealing with support structures and all those things that slow down the post-processing. So it's literally just pull it out of the powder bed and dust it off, and you're good to go. So yeah, probably speed. Yeah,
and Brian, so you mentioned, okay, so we're going to see hopefully make this a functional bike, but even beyond that, are there plans for more projects like this in the future?
Yes, absolutely. The design center, and going back to one of the reasons it's here, is it's inside of a museum with this vast collection of ideas, right? There's like 1,000 potential projects in here that we could pull any number of, legendary machines, championship winning machines and designs, and pull them into the studio and use them as a deep dive study and recreate them. I mean, there's ideas in here that go back to like the 20s and take a really old motorcycle that was made at a time when none of these technologies existed, and how could you revisit that and produce it today to inspire new ideas. So yes, absolutely. I cannot wait until the next project.
You almost don't know where to start, right?
Yeah, exactly.
Good problem to have. So when you tackle those down the line, should you do so, how do you plan on using the HP printer for it? What's the game plan with the printer?
I would say definitely more scale models, because I really had fun doing that on this project, and it's just such a fast way to get the whole thing and so accurate. I mean, this little scale model, it's a quarter scale, so it's like 18 inches long, and I mean, it goes together exactly the way the full scale model goes. And I scaled down the screws and the little fastening hardware too, and it goes together with the same accuracy. So it's just the detail is really impressive. So I want to do more scale models because obviously they take up less space, and we could do more of those. And then of course, getting into some actual metal parts. So we're using the metal, the multi-jet right now for a metal casting project. So we're actually using it to make patterns for investment casting. So that's an ongoing project with our restoration department, which is one of the top restoration departments in the world for these types of machines. And they come to me all the time with some kind of little obscure unobtainium part that they can't find anywhere. And let's say, for instance, a 1904 Indian cylinder head, we have one in the museum, and we need two because we're about to start a project to restore a machine that uses two of these cylinder heads. So we brought it up to the lab, laser scanned the original part, and we are right now producing a pattern that's going to be used in an investment cast situation. So we're using a polymer-based printer to make traditional, metal casting patterns.
Very cool. All right, so we have quite a few questions coming in. Hot topic, everybody wants to talk about it. So I'm going to just keep moving along quickly. We'll get to as many as we possibly can. Just to remind everybody, we also have Justin here as well. So I'm going to start going through these questions, continuing along. So, all right, coming up next. So, all right, what's the thinnest section you printed, and how does that compare to fiberglass thickness? Good question.
You said thinnest?
Yeah, thinnest. Thinnest section you printed. Yeah.
Okay, I'm pretty impressed with that aspect, and a few times I tried to push it, and I've seen on some of the parts done in the last month, like paper thin sections, and I want to say that the guidelines, the technical guidelines are like no thinner than like 0.2, I want to say, millimeters. I mean, really thin stuff for consistent results. But I mean, I've seen some really thin stuff, and I've even done more threads lately, threading in some parts that I knew we were going to end up tapping holes in. And these are polymer. It's a PA12 material, so it's nylon. So think of nylock nuts, right? So I started out printing threads down to, I want to say an M4, an M4 thread. At one point, I actually made a little prototype steering damper. It's like this little hydraulic steering damper, and it had M4 screws in it. So I just dropped the screws in the Model 2, and with being able to do like a caging feature in the build program, you just put a quick cage around small parts, so it prints everything in the cage, right? I printed M4 screws and actually used those screws in the prototype, just threaded them right into the hole. So I would say that's really high accuracy. I'm very impressed with it.
Yeah, and kind of in that vein, a second question from the same person, just about surface roughness. So what's the surface roughness of the printed parts, and how does that compare to, again, fiberglass?
Surface roughness, I would say if you take a part directly out of the machine, and we have our bead blasting room next door, so we're taking a part that you've brushed the powder off of, and then you're bead blasting it and pulling it out of there, and the surface finish, it feels like a kind of like a cast part, right? Like it has kind of like a casting. I wouldn't necessarily say it's rough because it's nylon, so it's like a smooth cast finish. It feels, it feels slick almost. And the more you use it, this is why we use it on a prototype for the steering damper, because it was a helical style rotary steering damper, and we printed all the parts inside. So we printed the helical spline inside and actually used that part in the production piece, because it's a nylon part and it's a helical spline. So it kind of gets slick over time because PA12 is kind of like oil based, right? So it kind of gets slicker and slicker the more you wear it, which is really neat. And I want to do more moving parts like that, moving part assemblies. But, we also dyed the parts. A lot of the parts on this prototype that you saw in the photos, the black central monocoque chassis, that is not painted. That is the actual material out of the machine. We just dyed it black, and that is the surface finish. I did nothing to that surface except blast the powder off.
Wow, that's interesting. So Brian, I'm going to pivot gears here for a second. This one's more kind of on process. So the next question is, have you found a good method for organizing print order of operations, breaking down a completely virtual model into your own instruction set?
If I found a good method for organizing the order,
yeah,
I guess for this project on this motorcycle, I was feeding the machine as designs were being released. So I didn't really have control so much of the print order. I was feeding, if I understand the question, I was feeding the machine as designs were being released. I didn't have them all at once. I didn't. If I did have them all at once, then yeah, I maybe would have came up with a different order. So I hope that answered the question.
Yeah, I think so. All right, so we're going to just do a few more here, and then we'll wrap up. And everybody, if we don't get your question today, there will be options for follow-up afterwards. I think you answered that. I believe you answered that. Bear with me. Okay. Bear with me for this next question. Okay, so yes, we'll take one more. What were the primary design objectives, and were they achieved? Is this possible without operating and testing a model?
Is it possible? Well, the design objectives, I think, were achieved at this point, because we were able to completely design the concept digitally and print it and make a physical model in the real world. And, I said it, this is all over a course of a month, but really the bulk of these parts, 90% of them was in like the last week of the project before the unveiling. So, I mean, it was just a massive amount of part dump all at once. And to be able to visualize your concept in the physical world that fast was almost a little surreal. It's like I've been staring at it on a computer over Zoom calls and chats and WhatsApp with Pierre for 4 months. Like we're working in this virtual space, and like everybody knows, stuff always looks different on the screen until you print it. And it's one of the coolest things about 3D printing is just physically holding the object in your hand that you've been staring at a screen for such a long time. But that was kind of surreal to me, because in a matter of days, what felt like days right at the end, I had everything printed and I'm assembling it in just this like record time. And it was just blowing me away that it was in full scale, and it was just an assembly project at that point, almost like you would assemble something in CAD. You're just kind of pulling stuff in from a library and snapping it and mating it, and that's all I was doing the last few days, and it was really cool.
Yeah, Brian, surreal and cool, to say the least, for sure, definitely. I just want to tell everybody, thank you for coming on today. I want to thank Brian. Just a reminder to everybody that if you have any questions, you can refer to the speaker bio box containing contact information for Brian, Justin, or myself. If we didn't have the time to get to it today, we can do so after the fact. And of course, I want to thank everyone again for attending this webinar from Design World. This presentation will be emailed to everyone later today and will also be available at designworldonline.com.